All right, let's look at limits with a graph. So using a graph to me is a lot nicer. I like this a lot better because you just have to look at something and kind of visually determine what's happening. So analyzing limits with a graph, it's really similar to doing it numerically or with a table. It's just the graph is a visual representation of that table. You just have a lot more points that are being looked at. So you still try to surround and close in on a particular x value and then look to see if you're closing in on a single function value or a single y value. So let's give it a go. So evaluate the limit using the graph. So the limit as x approaches 3 of that function is what? Well, you're going to do the same thing as we did before. You're going to come in from the left and then you're going to come in from the right. So if I trace towards the left, so I'm coming in to x equals 3, that left side, it looks like I'm going to hit or run into y equals 1. Now if I come in from the right side and trace along, so trace, 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 if I trace, it looks like as I get closer to x equals 3, I'm also going to get closer to y equals 1. So if you trace in from both sides, does it look like they would run into each other or connect? And the answer on this one is yes. They both approach the answer or the y value of 1. So the limit is equal to 1. Because remember, that's what a limit does. It's saying, hey, if you get closer and closer to this x, are you getting closer and closer to a y value or not? All right, let's try some more. All right, so here's our function g of x, and we're looking at it as x approaches -1 for this function here. So same thing, you're going to trace and as you trace along, what y value does it look like you're going to run into when you get to x equals -1? Well, that looks like it's going to run into 4. So your right side, trace, 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 and you get closer and closer to x equals -1. The y value in this case that it looks like you're going to run into is 4 again. So you're approaching the same value from the right and the left. So the overall limit itself is 4. All right, part C, if you traced in again, as you got closer to x equals 0, because that's what you're approaching, what y value does it look like you would hit? Well, it looks like you would hit 1. And if you traced in from the right side, so you get closer and closer to x equals 0, it looks like you're going to run into, you guessed it, 1 again. So they're approaching the same thing, or it looks like they would actually connect together at y equals 1. So now if we were in class, I would have you do D and E, like work in groups and stuff and discuss it, because these can give quite a bit of debate. So unfortunately, I can't do that here. So we can just kind of talk about it. So I'm going to approach from, I'm approaching x equals 0 from this side. So I trace and trace and trace, and I get to there, and there's a big old empty hole. Well, I'm not going to say, hey, approaches something that's undefined. What does it look like it's approaching? Like, what y value are you getting closer and closer to? Well, you're still getting closer and closer to y equals 1. Even though there's a hole there, it's all about what does it look like you're approaching, not where is the point. And then on the opposite side, on the right, you're also approaching the y value of 1. So even though the function is not defined there, you're still approaching y equals 1 from both sides. Like you're getting closer and closer to it. You can't actually hit it, but you're getting really, really close to it. Okay, and then this last one from the left, and then also from the right. And this is where people get a little confused because they say there's a hole there, but there's the point. So the tendency is they want to put what this is at, so they want to say it's 3. Well, that's not going to be the case for the limit. The limit is what does it look like you're approaching, not what does it look like you get close to and then jump somewhere else. It still looks like if you could trace in and get as close to this as possible, it still looks like you're approaching 1. So the limit is still 1. So something to kind of get in your heads is that limit values do not always equal function values. And this example and example D do just that. The limit value in example E is 1, but the function value is where the point actually is. So the function value is actually 3. So they don't always have to match up. For B, it did. The limit was 4, and then the function was also 4 because there was an actual point there. So sometimes they match, but sometimes they don't. All right, so I'll stop the video there. We'll go ahead and look at some other types of graphs in the next one and go from there.